Yeah, what we're trying to do today is to show everyone this tool called repp, which Janelia has done some, like modification with a previously published tool to facilitate our everyday molecular cloning task. I'll start by saying, like most of our molecular biology experiment or cell biology experiment actually start by molecular cloning. It really relies on the success of the molecular cloning. I'm showing you two plasmid maps here to say, like, what your molecular cloning might help you to do. For instance, you might wish to create a stable cell line to extract something called collagen 4 with a fluorescence protein fused with it, neon green. So what's in this construct is a lentivirus backbone, and it has this EF1 short promoter and this long coding sequence that comes from the collagen 4A2 locus with a flexible linker, comes with neon green, which is a fluorescence protein, WPRE, some regulatory elements enhancing the translation of the transcript. So you might also encounter another scenario where you want to knock in some tag or fluorescence protein or anything really into the endogenous genomic locus using CRISPR. This particular construct I'm showing you here has a very simple plasmid backbone with a left and right homology arm, plus this middle part is a halo tag with two flexible linker surrounding them. So what this construct is going to be used is to be injected into the mouse oocyte together with a CRISPR Cas9 protein and the guide RNA that will help the insertion of this halo tag as an endogenous fibronectin locus. So all these molecular biology tasks can or have to almost start from this molecular cloning. And one of the most versatile method people use now is called Gibson Assembly. There's a lot of available cloning methods. Classically people use restriction enzyme a lot. That kind of start to kind of fade away. It still have some usage for certain scenarios, but for general cloning, people tend to use either Gateway, Gibson Assembly, Golden Gate Assembly, or some other similar strategies. What Gibson Assembly can do is really you can seamlessly assemble somewhere around 2 to 6 different fragments of different size, as long as the fragments are designed to have at least 15 bases of overlap. So what is really cool about this assembly reaction is also it's just one part reaction. You can mix all your fragments together with a mixture of enzyme, including the 5' exonuclease, the DNA polymerase, and also the DNA ligase. Just after 1 hour incubation at one temperature, you get a bunch of assembled circular plasmid you can transform and go from there. So at each of the joint, the chemistry, like what really happened there is first the exonuclease will nick this 5' end of each of the strand, and it will expose this overhang that can anneal to each other because they have some overlapping sequence. And the polymerase activity will kick in to fill the gap here. And once they reach to catch up the other strand, the ligase can come here to seal it off. What's really making this strategy nice is, after it makes a circular plasmid, it is no longer amenable for all these enzyme activities. It's kind of like self-protecting once it makes a circular plasmid. So Gibson Assembly obviously is a very nice strategy, but you still need to think about, okay, now I have my plasmid I want. I have maybe like hundreds of plasmids in my lab collection, or some of my neighbor labs who are willing to share their plasmid with me. I may have accumulated hundreds to thousands of primers over the days of the molecular cloning. You may also have access to AdGene, IgM, or DNASU as your remote repositories where you would have hundreds of thousands of plasmids there. So what you really wish at this point is some handy tool that can take your desired plasmid sequence and query your collection or the remote repositories and just spit out some optimal cloning strategy. So you don't have to sit there and think about, okay, where should I PCR this fragment? Which fragment should I really just directly synthesize? And what kind of overlapping primers should I design? All those little nitty-gritty details. Those, of course, if you are doing 1 or 2 clonings per week, you can handle. But if you have, dozens of plasmids you want to generate in one batch, going them through one by one can take a lot of time. So this is the need. When I was thinking about this, after I arrived at Janelia, I was like, I got to talk with the SciComm. So I talked with Stefan to say, can somebody take on this task and come up with some smart strategy? And Stefan said, do you know if there's any available solutions? I'm like, not as far as I know. But he still kind of asked me to post this question on Twitter. And what's really funny is Mark from our SciComm replied to my Twitter saying, have you checked out this thing called repp? I was like, oh, never heard about this. So it turns out this repp or repository-based plasmid design tool, which is a Go-based command line tool, was published in 2020. I was imagining maybe these authors were kind of getting a little bored when they are in COVID, so they are trying to make good use of their time. So they realized this task, right? I got really excited, so I went to their gate and tried to install them and run them. And of course, all these things, if there's one person maintaining them, it could be really hard to get compatible across the different platforms. Long story short, I have a really hard time, to make it work. And also, their default features after Christian kindly helped me to figure out how to properly install the latest version of the Go to make everything compatible. It's still just it's a semi-working workflow because it gives you this giant JSON file with lots of unnecessary information that then really makes you feel I wish somebody can parse this into a directly usable format that I can just take and run this and get a cloning strategy, order my reagents, and then just be happy with it. Instead of having to kind of go into this JSON file, trying to parse, understand what each of the entries are and which part is needed, which part I need to order. So Christian from the SciComm has spent a lot of time on this, and so far I'm very happy with the task. Is one of our most used tools in the lab because we do a lot of molecular cloning. So this is how you would go for your everyday cloning if you have repp. So I'm making some screenshots here. For instance, this is my plasmid I want to make called PW256. If you care to know what it is, it's really a constitutive promoter, EFA short promoter driving a kinesin fused with M-scarlet with the red fluorescence protein in a lentivirus backbone. So in the same folder, I have some fragment database and primer database, which I will talk about what they are, and also your lab plasmid collection. In our current lab plasmid collection, we actually have several hundred of plasmid already. Some are received from Adgene, some are donated from our collaborators, some are plasmid we made previously. With this sequence and all this database, including the primer database and fragment database, and the plasmid collection, what you can do is you can simply run these commands in your terminal. Of course, you need to install repp, which I can show everyone step by step after this few slides. Is you can go to this folder and you first run repp add database to read in all these existing plasmid inside this lab plasmid collection, giving it a name. The name of this database is called lab, and the cost is 0 because it's directly accessible. And then you can run another line of command, say repp make sequence. Input parameter is this gene bank file of the plasmid you put together. And you want to use the database of the lab, and you want to specify the primer database and the fragment database. And it will give you these 2 CSV files that's properly formatted, that's directly usable for your downstream task. I'm going to show you how these 2 output files look like. If you open the output reagents, you are going to see the primers you need to order, which are not marked by the asterisks. The ones marked with the asterisk are the ones that's already found in your primer database. And you have the synthesized fragment, which overflowed in this cell. It's like a pretty long sequence. Some of the existing fragment in your database you previously synthesized will again marked by an asterisk, but the new ones you need to synthesize are these guys. And another file is called the output strategy. The strategy here will tell you, okay, you have now one solution with the cost of this many dollars, adjusted cost, which Kristen can tell you more about all these other parameters. But basically, you have now 3 PCR fragments and 2 synthesized fragments. And they are in this order, and for each of the PCR fragments, it will tell you which primers to use, which PCR template to use from your existing plasmid collection, what is your expected PCR amplicon size, and all these additional parameters that can help you to decide whether the synthesized fragment is reasonably difficult or easy to synthesize. Again, Kristen can tell you more about this part, but usually for your everyday task, once you reach this step, you can simply go here, order these 4 oligos from IDT, this synthesized fragment from Twist. Once they arrive, you basically print out this strategy thing, put it on your bench, you pipette. And then you can just get your, without much of the thinking, because all the thinking work is pretty mechanical, that has been handled by repp. So if you want to install and test the repp, I would suggest you can go to our lab website. Under resources, we have a lab protocols. Then you can follow under molecular cloning, there's something called repp-assisted plasmid design. This will take you directly to a quite detailed installation instruction, which I'm going to show you right now. So this is how they look. If you go here, you basically have a short introduction, and there's a recommendation of installing Git. If you are familiar, of course, you can step that. You can then install the Janelia SciComp version of the repp, first by installing the 3 dependencies, which is Go, Primer 3, and Blast. After that, you can then clone the repp of the Janelia SciComp version of repp from this link here. And then, if you don't like to install Git and you just don't want to use it, you can just go here, download the zip folder and unzip them. And this is, how you install them. And on Mac and Windows, this is how you copy the executable to some folder you prefer. So assuming you already have repp, I would recommend you download this repp test folder, which has all the required files for the minimal testing. So I'm just going to do this as instructed. Okay, I'm going to click on this. Now I have the repp test zip folder, zip file in my downloads folder. And I'm going to unzip this and follow exactly the instructions. Okay, now I have the repp test folder inside my downloads folder. I'm going to open a terminal. So if you want, feel free to follow me, but otherwise you can just watch, this is how easy repp can make your cloning task to be, right? So you can CD into downloads and the repp test. So here, like I said, we have several folders: the fragment database, the primary database, and the lab plasmid collection. So I'll just unfold everything. So in the instructions here, we actually have this optional choice. If you do care to use the plasmid available from Antigen and other repositories, you can use you can download this available repp database from something that's put together by the original repp author, and add those database to your computer. And just know that adding this database seems like a lot of tasks, but once you add a certain database, it's going to be always in your computer available for repp to use. So it's a one-time thing. So more importantly, you should well, not you should, but because the DNA synthesis cost has been lowered by quite a bit. In Twist, you can synthesize at 9 cents per basis. So a lot of times, it's actually more cost-effective to just directly synthesize a fragment. You don't already have a template to PCR from. So getting something from Antigen, first of all, it's costing $85, no longer that cheap. Plus, it will take time. So we now, rarely would go with the Antigen option. That's why we kind of try to downplay the importance of the remote repository. But you should definitely add the sequence database from your existing plasmid, available from your lab or your neighbor labs and the friends lab collaborators. So this is a command to do that. That's what I'm going to do. So you can really just come here to say repp add database, and you will give it a name, which is called did I just name called lab, and cost is 0 because it's directly available. And then you can say lab plasmid collection. I was using tab complete in case someone is not familiar with the command line. So after this, you have this report. It will say, okay, we have this config file, we have this features JSON, blah blah, and it will tell you how many files it reached successfully, which ones are duplicated sequence IDs, which ones have been skipped, which ones had errors. All these things were built in by this feature. Actually, was added by Christian. The original repp author was counting on people assembling a FASTA database already, but we can now just work with existing individual gene bank files inside a folder. So now you basically have your lab database that contains this full plasmid. You can then, here I was in these instructions, I was basically explaining why you may want to organize your primary database and your fragment database. For your primary database, it makes a lot of sense because it's very likely you will run into reusing some of the pre-existing primers, and the simple question is why not, right? You can put them in some boxes, number them properly, and you can always come back to them if they become useful in your future clonings. So we actually recently have this enhanced feature again implemented by Christian. Inside the primary database, you can see we have an archived primer spreadsheet and an active primer spreadsheet. The reason for that is sometimes your primer list can grow to be super, super long, right? If you have thousands of primers, it would be nicer if you have an archived primer, which you don't have to scroll all the way down by 20 pages, and then you can add new primers to the bottom. Once your active primer grows to be several hundred or something, it becomes inconvenient. You can just copy most of them. I would suggest leave at least one because how the new primers work. The ID of the new primers will increment from the available primer ID of your active primer list. Anyway, the point is I have this split of two primer database, or if you like, you can also have archive1, archive2. It doesn't really matter as long as your alphabetically last available spreadsheet is your active primer. It's going to be fine. So similarly, the fragment database is if you want to reuse your synthesized fragment, because again that could take some time to be synthesized from twist and arrive in your lab. So similarly, the fragment database parameter can take up a folder containing multiple spreadsheets, where again you can maintain a relatively short active fragment database together with one or several of the archived ones. So now it comes to okay, you have your database all organized. You need to, of course, know what kind of final product you want, which is this pw256.genbank. It's already open. That doesn't seem to be already open. Okay. I was trying to make some recommendation for this ape program for plasmid editing. It's I don't think it's completely open source, but it's a free software written by Wang Davis from University of Utah. It's very handy. It's very flexible. It can do most of the feature annotations and alignment and generate a reasonably useful map like this. Of course, if you like some advanced features, you can use SnapGene or any of your favorite like DNA editing program to do that. But once you assemble this by copy pasting some of the existing, promoters, any elements together, the remaining part is simply by going to your command line to run repp make sequence. You specify the input, and then you specify which database you want to use. You don't have to if you only have one database on your computer. But because I have already added my AdGene, DNSU, and IgM database, but for this particular example, I only want this program to use a lab database. This is why I specify the lab database. I will specify I want to use a primer database inside the primer database folder, and the synthesized fragment database specified by the flag S. And then you can enter, and all this alignment, finding the proper fragments, designing the proper primers, and the synthesized fragments are all handled by repp in the backscene. And after running that, now you basically have these two very useful CSV file, as I was talking about in the slideshow. So now you basically can come here, copy these new primers, and order them from like IDT or something else, and synthesize oligos here from twist. And you can come here, print this spreadsheet, and again put on your bench, pipette. So that is repp, and that is how you usually go with repp. There's a lot of additional parameters that can give you some more sophisticated control of using repp, which Christian can tell you more about. But if you have questions, I'm happy to answer. Okay.
I guess one question I had was about that this was kind of a detail, but that part where you pull down I think it was AdGene database, and you just get like a file on your computer with like all of their sequences. I'm just curious if there's any way that, because then that's like a one-time thing, and then if new things get added
to AdGene,
your database doesn't get updated, right? So
yeah.
I was just curious if there is even like a feasible technical solution where you could like, I don't know, somehow be like listening to AdGene and like periodically pulling.
Yeah, we actually kind of talked about this, but again, first of all, because of the direct synthesis is often reasonably cheap and quicker. So you don't necessarily really want that. Second is, like a lot of the reusable backbones are already included in even this slightly older version of the Adgene. Honestly, I even tried to contact Adgene to ask for an updated version or some API. They just ignored me. So, another feature we talked about is about DNA synthesis, right? Because sometimes you want to synthesize this particular fragment, you put it in Twist, it will run some secret algorithm to decide is this really synthesizable. Most of the time it's okay, but occasionally we do run into some problem to say this is difficult or impossible. And when that happens, we basically have to come back to either use some trick to say split this fragment into two or re-encode certain coding regions so that reduce the repeat region or something to make it synthesizable. So what I'm trying to say is it's not perfect, but for everyday usage, it's good enough. Christian can comment on that. If we can somehow have some better relationship with Adgene, for instance, get an API from them, I think listening to their database is probably not a bad idea at all.
I was just curious because I feel like that's probably a somewhat common need. People are building software that depends on some public database and they want to have it regularly updating. I'm
sure they have some internally available API. It's just a matter of whether they are willing to kind of open it. I mean, Adgene in theory should be, but since they ignored my email, I don't know. So Twist, same thing. You would think we are basically trying to promote their business, right? Because if people routinely use this, they can more easily decide, okay, I want to synthesize this fragment or redesign it. But they just don't.
Yeah.
Are there any strategies so you need a target sequence to make? You've already created that. Mm-hmm. How do you create that? What would you suggest for making that sequence?
You mean you may want something like a ChatGPT to say, I want something to express this in this.
That would be nice, but I don't expect that. Yes.
I mean, I would say in the future, if somebody is really into it, that is possible, right? Basically to piece together some of the fragments. Right now, we basically rely on people's kind of expertise knowledge to know what promoter they want and to get those sequence from either the genome or some existing publications or an existing plasmid or a previous plasmid somewhere. It actually nowadays almost no plasmid comes from nowhere, right? It always comes from some here and there you piece them together. I think what repp saves you is after you already piece them together, you don't have to go in and say I want this fragment to come from here to do this primer, and I need to extend 10 bases here to overlap with this part. Those part is kind of not really intelligent, but more mechanical, and it's error prone. Yeah.
I can appreciate it. I'm just curious whether you have any suggestions for deciding on even codon usage in your final sequence, depending on organism. So, are there any software packages you'd recommend for that?
I don't know if there's a one part in all, but depending on the organism you are working with, there are C. elegans, for instance. Tony Hyman has this website tool where you can go in and optimize a codon for C. elegans.
Right.
I imagine most of the existing codons is already optimized for mammalian expression, so you don't necessarily need to worry about that. But for other organisms, especially if they're not standard, the best thing you can do is basically to go to some of the codon usage table and trying to what I'm trying to say is there's probably not really a existing software package that can just give you the answer.
Right.
But Tony Hyman's website might include not only C. elegans, but quite a few different organisms. I'm not quite sure. You can check.
Okay. Thank you.
Okay, if there's no more questions, I'll give it to Christian to talk more about how repp works, maybe like algorithm-wise and like some available options and parameters we can tune to kind of make it more customized.
Okay, so Shaohe pretty much covered the commands that I actually want to address. I will just go a little bit more into details and how to find out how to use actually this command line tool. As Shaohe mentioned, and I learned a lot about how he uses this in his lab. I only knew the command line, but I didn't know exactly how he builds everything. So I learned a lot today. So the command line, in my case, I basically use the version that I build usually, and to install it, oops. To install it, I use on Mac, I use brew commands to install the NCBI tools and Primer 3. These are two tools that are necessary for running repp. And on Windows, to install Go, Shaohe has his own way to install it, and he has the links on the website to install it directly from there. Or you can use, if you're familiar with command line tools on Windows, you can use Scoop, and that's what I use to install Go or other tools that are needed, like Make, and there are some other Go linters that are needed in order to build the tool itself. Once you have the tool built, the simplest way of finding the commands that are available, it's by just simply typing the tool, and it has multiple commands, and you'll see here all the commands that it has available. One command is add. You can just continue with add, and then you can see that the option here are database, engine, or features. These can all be added, and Shaohe already showed you how to add a database. And at every point, you can just type -h or --help, and that will tell you the flags that are available. And there are some flags that are specific to the add database command, like cost, help, name of the database, and there are some other flags that are global for the entire tool, to the entire tool. They are not command specific. One of these flags is this repp data dir, which specifies where your database, your repp databases will be located. To understand what a repp database is nothing but it's only a blast database, and it's all created using the NCBI make blast DB. That's the tool that it's actually used for creating a database, or what's called a database. And right now it doesn't have any update features. If you just run add database and you use the same database name, it will simply replace the existing database with a new one. And currently the sizes, and this is from the original code, the size of the files that are added to this blast database are kept to 10 megabytes. So at some point, when the file size reaches, or the lab collection reaches, or will be bigger than 10 megabytes, we'll just have to see how that works out, or maybe we'll just have to add some modifications. I don't know exactly how that works. That's something that I haven't I haven't looked into yet. So this is one change that we made so that we can specify the repp data, the repository data directory, just in case this tool needs to be shared or needs to share the the databases with a team, and then you work on an NFS mounted directory, not on your local laptop. You have this. We added this option to specify the rep data there. So he already showed you how to add a database by specifying the name of the database, lab by specifying the cost, the acquisition cost, and then a change that we made was specify the location. Before, the original tool only allowed you actually not even to take a FASTA file as input, but you had to cut and paste that sequence into the standard input. That option is still there, but it's a lot easier to just specify, to just go to your directory and specify where your location. You can specify a single file if you want to add, or you can specify a directory of files to add. And that's how the database is being created. That's for once the database is available, the next available command is being repp make, let's say make, and then type make. What can we make here? We can make features, we can make fragments or sequences. And I only looked more into make sequence, and this is the one that I changed because that's what Shaohe's lab needed. So make sequence, again, make sequence. If I can type -H. And then here it gives you all the options, and you can see here all the options that are available to the make sequence command. By the way, does everybody see the screen? Is this big enough?
Yes. Yeah, it's fine.
Okay. So the options here are, you have short options or you can have longer options. -D for specifying the databases. If you don't specify the databases, it will take all the databases that are currently registered in your data repository, or you can take a single one, or you can take a comma delimited list of databases. Another option that initially was just set to 98%. We default now the identity, and this is the identity parameter that is used by the BLAST database, BLAST NCBI tool, and we default that to 100% identity. Before it was just set to 98%. So if you want to make this the matching with your query, with your database, with your existing query, database a little bit more lenient, you can just lower the identity threshold. The input file is the one that Shaohe already showed you how to specify the input sequence. Now, from what I saw originally, there was only typically it returned one. Sometimes if you have multiple databases that you specified in the command line, it will return a number equal to the same number of databases that you return, a number of solutions equal to the same number of databases. Instead, I added this -n parameter, which specify how many solutions you want to be displayed in your final strategy file. The output, if you don't specify the output, it will simply build the output using the default extension based on the format. As Shaohe mentioned, the original tool used JSON as output, and that was the default. Now we added this mechanism to create two CSV files as output, and this is what we have currently as default. One file that for the strategy, for the cloning strategy, and one file containing the reagents. -M is the primer databases. -M can, because originally I just named that the -p flag was taken, so I used m from manifest. That's why I use -m, and then -s is for the synthetic fragments databases. And again, there are these common parameters, the configuration. In case you want to tweak your configuration, the twist config, you have an option to specify an additional configuration that will be added. If you want to play with your primer 3 configuration and you're expert in your primer 3 usage, you can tweak primer 3 parameters, and you have the option also to specify where your data is located. By default, just for everybody to be familiar, by default, the repository is stored under your home directory in a hidden directory called .repp. That's where your databases are stored, your primer 3 config, your original configuration, your default configuration that's already packaged with the tool. And as I mentioned here, these databases are nothing but blast databases. Currently, I only have one database registered. I can use the command to add another one, just name it differently. And now you can see here that now I have two blast databases. One is called lab and the other one is called something else. So that's so these are the flags that are used by the make sequence database. If we go to the output, one thing, does anybody have any? I don't know if it helps to just run the command again. I'm just going to use the same flags that Shaohe already used, the dash input. Maybe, yeah, maybe I can do make sequence -d, and then I'm going to just use lab minus input. And I have my data here, PS 11 GB. That's my input. I have what else do I want? I have my primers databases, but my primer database is again in the same location. For these primer databases, you have an option to use either comma delimited list, or you can specify a directory, or you can specify wildcards. Now, if I specify wildcards, I can use, for example, I have both my fragment databases and my fragments and my primers are in the same directory. So what I can use primer for .csv. Now, if I use wildcards, this is just because it's OS specific. I have to enclose this within double quotes. And for the synthetic fragments, I can use data. And it's, like I said, it's in the same. And just because I don't want them to, instead to use or mix synthetic primers or synthetic fragments, synthesized fragments with primers, I can just specify I want files that look like this. And again, because I'm using a wildcard here, and this is not because of the tool, this is just because of how the OS expands the input parameters. Let's say that I want, give me my top 3 solution, and then give me my top 3 solution. And actually, I want to show one more parameter. Let me just type dash help. Yes, it's this strange command line parameter, synthetic fragment factor. This is another parameter that we added to the tool. And when you run into this problem that your synthesized fragment is actually not synthesizable, you have an option to increase the cost of your synthetic fragments so that they would not show, or so that they be ranked lower than your PCR fragments. So we can use a synthesized fragment of 2, let's say, and that will double the cost of your synthesized fragments. And again, it's trying to fill two. It's bringing me here. It found 21 assemblies, and it's trying to fill the first 3 assemblies from there. So now I have here my solution. This is the strategy file that was generated. And you can see now that the adjusted cost now it's different than these costs. And that's because the adjusted the cost based on that factor that we specify for the synthesized fragment. This cost includes, so for synthesized fragment, it's all these values, they are all configured in the config file, and we can override this using the config file. I will show you how the config file looks. And these are the top 3 solutions that I asked for, and we can see which are my top 3 solutions, what they consist of, the reagents, and all this. Now about these additional fields that we have here. These additional fields are some, and you can see that they are actually set only for the synthesized fragments. And these are fields that Twist uses, or at least from what we found on their website, the probability to have a fragment for a fragment to be synthesizable is to have a low GC content. They said that they look at the highest and the lowest consecutive 50 GC content in the 50 bases, in the consecutive 50 bases. So these are some statistics that I output there just for somebody if they want to pay attention to that, to see, okay, how synthesizable is my fragment here based on these values. And they have some guidelines on that the GC content should be between, I don't remember exactly from the top, between I think 25% and 65%. They also, the difference between 50 low and the highest 50 should be within certain limits. We don't compute that, but this is the purpose for having these additional fields. They also look at the longest homopolymer. Currently, in our case, for this one is 5, for this one is 6. We don't list those yet, but we could if need to. These are the additional fields that we added to this output. And then for the reagents file, this is just a list of reagents, just the corresponding sequences. And again, we have the reagents that are used by different solutions. And you can see that the numbering starts over from each solution, just in case you want to pick up the second solution instead of the first solution. You can pick these primers, you can pick the OS 184. This is just a simple naming scheme, and the same thing for synthetic. The ones that are marked with an asterisk are the ones that we currently have in our databases, in our fragment database or in our primers database. These are some flags that I actually wanted to mention. If you have questions about additional flags, I can try to answer. I don't know if it's worth going over the algorithm. The algorithm simply tries to create an assembly there by looking at the certain overlaps, uh, uh, which are all configurable in this config file. I will show you what my config file looks like, what the original actually config file looks like. And this is what the original config file looks. And you can override, and you can override this, and you can specify only additional properties that you want to change. You don't need to copy the entire file. You can just override certain properties. So they specify the maximum number of fragments that you can have in the assembly, the junction length, the hairpin. These are all properties that are used by this for creating this assembly. The cost, and these are used for estimating the cost for per PCR reaction, the time cost. Right now it's just set to 0. You can increase this, and then of course this will be added to the cost. The minimum length for your PCR fragments, the max pair penalty. These are all values that are used by primer 3. The whatever Shaohe probably knows what these parameters mean. They are just used by primer 3 and for determining or getting the best primers for a specific fragment. Configuration for the minimum primer length, for the maximum primer length, optimum primer length, the homopolymer. Now, again, this is something that we found out that in certain cases it would return primers that were not that could lead to certain problems, and that was because certain settings in for primer 3 were just set to be more lenient. So now we increased that and we made it a little bit more strict. There's for primer 3, there's this parameter primer peak anyway, which initially was set to true. And it would always pick something, a primer, even if the primer did not meet the annealing temperature constraints. Again, fragments, parameters for the synthetic length or synthesized fragment lengths and so on. And before we had that parameter for the synthesized fragments, I think Shaohe used to go here and increase the cost of the synthesized fragment just to have the PCR fragment come before the synthesized fragment when it came to sorting the solution for this. Now, so this is the config file, and as I said, you can just take certain parameters from here and just override those properties, and to run that, you would simply just use an additional -c command or --config like this, which is a global parameter. This is the parameter if you want to override certain parameters. So this is what this is how you would use this for a command from the command line. Just one more thing that I want to show you, and then I'm done. You have an option. We created a few workflows to run this from our Nextflow Tower instance. So at some point, Conrad had a tutorial or a how-to tutorial about how to use Nextflow Tower, and this we created a few workflows for running this plasmid assembly. So that would be just by simply creating a pipeline for running the plasmid assembly. If you select this and you go to launch, well, of course, this is in my account, and if one wants to use this mechanism or to run repp, they would have to create and set up their tower instance to have this pipeline. And also it's a little bit more complicated because it requires a compute environment. So you really, if you need help, I can help you setting that up, or you can just watch Conrad's tutorial about how to use tower, Nextflow tower. And here, the workflow name, this is assigned automatically. Now here we have the options. These are the three options that we currently only have: add database, list databases, and make plasmid. If we add this, now by default, as I mentioned, and this is where it becomes handy to have that additional parameter for the repository. Just in case you don't want to put this in under your home directory, you have you can specify a different directory here. You can make it more verbose if you want to display some properties. That this is the name of the database, and this would be the path where this path. You can have this on NRS, or you can have this on any other NFS mounted volume. So, and you can see here that there are some options for the database. Right now, they are not distinguished. They're all in here, and you have to be careful when you run add database to just set the option specific for the add database. When you run make plasmid, you go to the make plasmid section, because right now it simply takes all the command line parameters and it passes them all to the tool. But of course, if you just run the make plasmid command, it will only use those that are specific to the make plasmid in Nextflow. And you simply just, yes.
There is another meeting in this room.
Yeah, that's pretty much all I had.
So, yeah, if there's any concluding sentence, get it out now, but we should wrap up.
No, I think I showed everything that I wanted to show with this. And if anybody has any more questions, if they want to use the Nextflow tower, they can just ask me directly, and then I can help them setting this up.
Awesome. Well, thank you so much. And yeah, unless there are any questions, we'll wrap up there. Okay. Thanks, Christian.
Thank you.
Zoom.